So in today's episode we will finish off the implementation of our storage system, so let's start right away. First off, we will open up our BP storage and add a new variable here. That will be a chest reference, so search for BP_chest reference and make that editable and exposed on spawn. Now let's right click somewhere and search for add event begin play. And what we will do is get the top-down char reference, get its inventory reference, get the main widget. Of the main widget, get the storage. Alright, so we will get the storage here and promote that to a variable, which we will just call storage widget. And after we did that, same as in our inventory, we have to get our slots array and resize that by the amount of slots. Then let's go down here to our update slot at index function that we didn't implement yet. For that we will get the storage widget, get the slots, then get from that array at the incoming index, and simply call the update function. Also we will need some new functions here. First one will be called show storage, and what that will do is get the storage widget, set visibility to visible, and get the top-down char reference, get the inventory, and set storage open to true. After that we will return. Then let's duplicate the function, call that hide storage, and just change it to hidden and the boolean here to false. Compile and save. Now we also have to add a much more complex function to actually move items from the inventory to the storage and the other way around. So hit the plus sign here. This one will be called move from inventory to storage index. It will have 3 inputs and 1 output. The output will be a boolean called success ? First input will be the inventory, which will be a BP inventory reference. Then the next one will be the inventory index, which will be an integer. And finally another integer, which will be the storage index. First off, we will promote all of the inputs to local variables. So local inventory. After that, local index. And finally, local storage index. Then let's get the local storage index and check whether that is an empty slot. So is slot empty. Hold B left click to add a branch. Connect the empty to the condition. Let's do the true path first. So if it's true, get the local inventory and search for get amount at index. The index will be the local inf index. Then we will take the amount here and promote that to another local variable called amount to add. Connect that to the true here. Then after we set that, we will call the function add item to index. The index will be the local storage index. Amount will be the amount to add. And for the item class, we have to drag off of the local inventory, get the slots, then get from it, add the local inventory index, break the result, and then connect the item class. Off of the success, we will add another branch. If it failed, we can return with false. But if we were successful with adding the item to the storage, we have to remove it in the inventory afterwards. And we will do that by dragging in the local inventory, search for remove item at index. Index will be the local inventory index. And the amount will be the amount to add. After that we can return, but this time successfully. Alright, that's it for our true path. Now let's go to the false path. First thing to do is add another branch, connect it to the false. For the condition, let's get our slots array, get from it, add the local storage index, break the result, and drag in the local inventory, get the slots array, again get from it, add the local inf index, break it, and we will check whether the item class from our storage equals the item class from the inventory, and hit the plus sign since we will need 3 conditions here. For the second one, right click and get item info at index. Index will be the local storage index. Then break the item info, expand it and connect the can be staked. For the last condition, we will check whether the amount at the local storage index, so get amount at index, is less than the maximum stack size. Connect that to the end and connect the end to the condition. If it's false, return. Again with false. But if it's true, let's set the amount to add. For the in amount, let's add a select node. Select integer. The a value will be the maximum stack size minus get amount at index. And the in index will be the local storage index, and connect it to the minus and the minus to the a. So basically that's the amount of items that can still be added to that index. And for b, we will get the local inventory. Again, get amount at index, and this time plug in the local inventory index. Then connect the amount to b. Finally, we need our pick a boolean here, and that will be that the amount at the local inventory index is greater than the maximum stack size minus the amount at the local storage index. Connect that to the pick a. Then after we set the amount, we will call the function named increase amount at index. The index will be the local storage index, and the amount to add. Of the success, search for branch. If it's false, we will return with false. But if not, drag in the local inventory, remove item at index. Index will be local inventory index, and the amount will be amount to add. After that, return with true. Pile, save, and that's it for our function. Let's actually select everything here and hit Ctrl C to copy it, because we still need a function to move things from the storage to the inventory, and that function we will implement in our BP inventory. So close the storage, open BP inventory, and let's add a new function which will be called move from storage to inf index. Then hit Ctrl V to paste it. Connect that here. We will need 3 different inputs. First one will be the storage, which will be a BP storage reference. Next one will be the storage index, which will be an integer. The last one will also be an integer, and that will be the inventory index. Let's remove the first 3 nodes here and promote those to local variables. Next, the local storage index, and finally the local index. And when we hit compile, you will see that some errors appear here. So let's right click on the local inventory index and replace that with the local storage index. Then delete the local inventory here, and instead we will drag in the local storage. Off of it, search for get amount at index. Let's actually control click the amount here and drag that over to the new node. Remove the old one and connect the local storage index. Also search for slots and connect that to the get node here. Then remove the old node. Here right click and replace it with the local storage index again. Then right click on the set amount to add node here, and we will create a local variable called amount to add. Then compile. Here when we add the item to index, we will replace the local storage index with a local inventory index. Compile and save. When we check for the slot empty at the local storage index, replace that with the local inf index. Compile and save. After we add the item to index, let's replace the local inventory with a local storage. Search for remove item at index. Delete the old node. Connect it to the true path and to the return node. Also check the success in the return node. Connect the amount to add to the amount. And the index will be the local storage index. Then delete the local inf index here. Compile and save. Now let's go back into the force path. To our left, we will replace the local storage index with the local inf index. Then down here, replace the local inf index with the local storage index and drag in the local storage. Then get the slots. Replace the old node here and connect the slots to the get node. Here again, replace the local storage index with the local inf index. Same as down here. And here again. Down here, when we get the amount at index from a local inventory, we will delete the inventory, drag in the local storage, search for get amount at index, control click the amount of the old node and drag that over to a new node. Delete the old one. Delete the local inf index and drag in the local storage index. Then when we increase the amount at index, replace the local storage index for the local inf index. Here when we remove an item, drag in the local storage, search for remove item at index, connect the amount to add to the amount, and drag in the local storage index for the index, remove the old node, remove local inf index, local inventory, and then connect it to the execution and make sure that you check the success in the return node. Now we should be able to compile and save, and we removed all of the errors. Alright, now let's close the BP inventory, go to our drag and drop folder and right click, create a new blueprint class. Under all classes, search for drag and drop. Drag drop operation, that will be called storage slot drag. In here, create a new variable, which will be the slot that we're dragging around. That will be of the type storage slot reference, editable and expose on spawn. Compile, save, and you can close it. Then let's go back to our blueprints and double click to open up our BP chest. Right click somewhere, add custom event, which we will call on storage closed. Compile, save. Let's actually keep that open, we will need it later. Now we will go to our widgets, to the storage widget, hop over to the graph, event graph. Then let's select the close button and add an OnClicked. So when we click our close button, we will get the storage actor, get its chest reference, and off of it call the onStorageClose. Now let's also do the onSlotClicked event. So every time we right click one of our slots in the storage, we will try to move it to the inventory, but without any specific slot index. We will just try to add it somewhere in the inventory. And to do that, let's get the storage. Off of it, get the slots. Get from it. The index will come from our slot, so the slot index. Connect that to the get node. Then break it here. And the amount we will promote to a variable that we can call amount to remove. Connect that to the execution path here. After that, let's drag in the player inventory, and now we will try to add an item. The class comes from our break node as well as the amount. I will leave the show notification unchecked. Off of the success, let's add a branch. So if we were successful, let's get the storage actor and remove item at index. The index comes from our slot index, and the amount will be the amount to remove minus the rest that was not added. Connect that. Actually, let's go to our storage slot first and add a function called reset style. What that will simply do is set dragged over to false. Then get the button, slot button, and set style. And for the install, we will drag in the default style. After that, simply return. Now compile save and back to our storage widget. After we remove the item at index, drag off of the slot and call reset style. Compile and save. Then let's actually select everything here. Hit Ctrl C to copy it. And now let's go to OnDrop. So when we drop something here, let's cast the operation to item drag. And when we drop an item here, let's paste everything we copied. First off, when the cast fails, let's go to the return node and return with false. But this time we have to get the slot, get the index, connect that to the get node here, delete the old one. Then here replace the storage with the player inventory and get its slots, connect it to the get node. Also, we don't want to add it to the inventory, to the player inventory, but to the storage. So search for add item. And remove the old one. And connect the success to the branch, the rest to the amount to remove minus. And here we will delete the storage, drag in the player inventory, and call remove item at index. Also, we don't need the reset style node. Connect the amount to remove minus rest to the amount. And the index will come from a slot index all the way to the left. Then finally, let's copy over the return node and add it to the branch here. When it's false, we will return with false. Paste it a second time, and if it's true, we will return with true. Alright, that's everything for our storage widget. Let's go to the storage slot now. First, in our function called onMouseButtonDown, when our slot button is enabled and it was the right mouse button, we will not return, but we will get the storage reference, get the storage widget, and call the onSlotClicked event. After that we will return. And we have to make sure to get a reference to our cells and connect that to the slot. Compile and save. Then let's go to onMouseButton double-clicked. Let's delete the item info and break as item info down here. And remove the third condition of the branch just by right-clicking and remove pin. So when that's true, do the same thing we did before. Storage reference, storage widget, and call on slot clicked. Slot reference will be our cells. After that we can return with handled. Compile and save. Then go to the event graph, and down here there is our event onDragLeave. And the only thing we'll have to change is when the cast to item drag fails, we get the operation and cast it to the storage slot drag. And if that one is successful, we will also go into the set dragged over to false and set style to default style. Also under drag and drop on drag over, we have to do exactly the same thing. So when our cast fails, we will get the operation, cast it to storage slot drag, smooth everything over. If that fails, we will go to the return node. But if it's successful, go to the set dragged over to true. Also, we will go to onDragDetected. And after we create the dragged item widget, we will create a drag and drop operation of the class storage slot drag. Connect the return value to the return node. The pivot will be mouse down. The default drag visual will be the return value of create dragged item widget, and the slot will be our cells. Finally, there is one more function that we have to change, and that is OnDrop. So first off, we will cast the operation to storage slot drag, just so that we can drag around the slots in a storage just as we can do in the inventory and change their position there. So when that is true, we will get the storage. And we will try to add to index. For the from index, let's drag off of the as storage slot drag, get slot, and get slot index. Connect that to the from index, and the to index will be our slot index. So connect that. Then add a branch off of the success boolean. If it's true, we will return with true. But if not, we will drag in the storage reference once again and call swap slots. Index 1 will be the slot index of our dragged slot, and index 2 will be our slot index, just like in the add to index function here. And after we swap the slots, we will return with the success boolean from our swap slots node. Alright, all of this happens when we're dragging around storage slots. But if not, we will cast the operation to item drag, which means that we will then have to move an item from the inventory to our storage. So to do that, drag in the storage reference, call our function here, move from inventory to storage index. The inventory we will get from the as item drag by getting the slot and getting its inventory reference. The inventory index will be the index of the drag slot, and the storage index will be our slot index. After that we will return, and the return value will be the success of the function. Then off of the cast failed, we will add another return value, and this time that will be false. Alright, that's it for our storage slot. We can now close that one and open up the inventory slot. on the event graph. Let's go down here for event on drag leave. Here again, let's add some space, and when the cast fails, we will cast the operation to storage slot drag. Same thing goes for the on drag over. When our cast to item drag fails, get the operation, cast it to storage slot drag again, and if it's true, go to the set dragged over to true. If it fails, go to the return node. Then let's go to OnDrop, and again cast it to storage slot drag when our cast to item drag fails. If that cast fails as well, we will return with false. But if not, let's get the inventory reference, and we will call move from storage to inventory index. Then off of the storage slot drag, get the slot, get its storage reference, connect that to the storage of the move from storage to inventory index node. Off of the slot, get the index, connect that to the storage index, and the inventory index will be our slot index. After that, again return with the success value. Let's also override the on mouse button double click. Let's actually cut the item info and break node. Remove the pin from the end condition. And if it's true, we will get the inventory reference, get storage open, add another branch. So if the storage is not opened, we will paste what we had before, expand it, get the can be used, add a branch, connect that to the false, and if it can be used, we will use the item at index. If not, we will just return, and for the return value search for handled. But if the storage is opened, we will get the inventory reference, get the main widget, get the storage, and this storage is just the storage widget, so off of it we'll have to get its storage, which is kind of confusing actually, so maybe you should use better names for that. And off of the storage, search for add item. The amount will be our amount. For the item class, drag off the inventory reference, get the slots, get from it, index will be slot index, break it, connect the item class. Then off of the success, add a branch. If we were not successful, we will return with handled. But if we were, let's drag in the inventory once again, remove item, add index. Index will be slot index, and the amount will be our amount variable minus the rest that wasn't added. Then we will go into another return node and again return with handled. Compile and save. Now we can close the inventory slot and go back to our NearbyChest. In here, let's hop over to the viewport and add another component, which will be a sphere collision. Let's call that our interaction range and give it a sphere radius of maybe 300. That worked for me. Compile and save. Then on the event graph we will add another event, which is called OnInteract, which will have an input, and that is the top-down character. So for the type, search for top-down character reference, compile, save. Then let's open up the top-down character and create a new variable called NearbyChest. This will be a chest reference. Compile, save. And now when we press E, there is no nearby pickup actor and there is no nearby merchant. Then we will check whether our nearby chest is valid. Connect that to the is not valid. And if it is valid, we will call OnInteract. The top-down char will be our SaaS. Compile, save, and let's go back to the BP chest once again. Select the interaction range. Add 2 events here on component begin overlap and on component end overlap. We will cast the other actor to the top-down character. And if it is the top-down character, drag in the chest text. Set visibility to visible. And off of the top-down char, set nearby chest to a reference of ourselves. Then let's copy all of this, paste it down here, connect the other actor to the object and to the execution here. But this time we will set it to hidden, so uncheck the new visibility and remove the self, so we'll just clear the nearby chest. Then let's define what happens when we interact with our chest. So first off, just like we did in our merchant, we will add a doOnce node. So what we'll do is set our top-down character variable to the incoming top-down character, get our storage actor, check whether it's valid already. If it's not valid, we will spawn actor from class. Class will be BP storage. You can right click on a spawn transform, split it and leave everything at the default value. Collision handling override will be set to always spawn ignore collision. For the amount of slots, drag in our variable. Slots per row, do the same thing. Top-down char reference, also drag in our top-down character reference. And the chest will be our cells. Connect that to the is not valid. And set the storage actor to the return value. Then let's drag in the storage actor. Get the storage widget. And call generate slot widgets. Also connect it to the is valid and to the set storage actor. The storage will be our storage actor. Then after we did that, off of the storage actor call show storage. After that we will drag in the top-down character, get his inventory reference, and we will call hide inventory just before we show it again. Like in our merchant, that is used to get rid of, for example, the throwaway widget if it's visible at that time. Compile, save. Off of the top-down character, search for disable movement. And off of the character movement, search for stop movement immediately. Now that's everything for OnInteract. We also have to do onStorageClosed finally. What that will do is just get the storage actor and hide it. Hide storage. Drag in the top-down character. Then search for set movement mode to walking. So a player can move around again. Let's get the inventory. Search for is visible. Hold B, left click to add a branch, connect it to the condition and to the execution. Now when our inventory is visible, we will call hide inventory and afterwards show inventory. Before we will reset the doOnce node. Also we will reset it when our inventory reference is not visible. Compile, save, and that should be everything for our chest, so let's hit play and test. pick up the stones and our hero swords. Maybe some health potion. Let's actually split the stacks here. Let's open up the storage here. You can see it appeared here. We cannot move around. If we close it, we can move again. Then when we open it up, and let's just double click a hero sword here. Now we can see it appeared in storage here. If we get a stone and drag that to a specific slot here, it was added to that slot. However, we can still get it and move it to other slots here. Also, what we could do is split it and drag in the two split stacks, and here we could recombine them again. Or we could drag in the health potion and drag some other health potions directly onto the other health potion slot in the storage. See it updated here. Now when we right click something, we picked it up again, or when we right click on the health potion, we pick them up, and you can see that our weight and our overloaded is still updating. Alright, that's it for our basic storage system. See you in the next video.